Hello, guys. I'm going to go ahead and work through the 5-7 task to answer any questions that you might have. So notice here that we have I is a 0. And just like we did in our previous sections, I'm going to write down our different topics here. And if this is a 0, then this is a factor. And if I do division, I would get a remainder of 0. But because it's imaginary, there's no x-intercept, okay? So let's do the synthetic division. That would show this. I. Now be careful that as we are working here, okay, 1, 1, 1, 1, 1. Okay, you need to plus I. Whoop, plus I. When you multiply 1 plus I times I equals I plus I squared, which is I minus 1. Okay, you have to make this substitution if you want MathSpace to properly I minus 1. Okay, add, just I, nice, okay. All right, multiply again. So let's see. I times I is I squared, which is negative 1. So you have to write the simplified version. Otherwise, it will say that you aren't finished with it. Oh, okay, so notice the red spot right here. Okay, that's the part. Oh, that's because I mistyped. Okay, let's try that. All right, is it a 0? Yes. Now, just as some side information here, if I is a 0, so is negative I because of the conjugate root theorem. Okay, let's see what part B says. Is 2I a 0? Let's find out. All right, so I'm going to do a little multiplying over here. All right, so 2I times 1 plus 2I. Which is 2I minus 4. Okay. Add. I can kind of already tell this isn't going to be 0, but I got to finish the problem anyways. Okay, 2I times 2I minus 3, 4I squared minus 6I. Okay. Add. All right, let's see. Yay. No, it is not a 0. All right, let's go ahead and do the next question. Now, I'm going to mention some other information as I solve this, okay? It's telling me that I have x equals 3I. Now, I'm going to pretend I don't know what section this is. There are a couple ways to do this question. It wants the real zeros. And the first thing that I would always try for solving is factoring. Okay, so I noticed that I could do a little u sub here. Okay, so I'm going to solve it by factoring. U plus 9, u minus 1. Okay, so x squared plus 9, x squared minus 1. All right, so sum of squares is prime, but difference of squares, factors. Okay, so I did my complete factoring, which means that the real zeros are 1 and -1. But I'm going to show you some more work so that you understand how this information is connected. We kind of have two choices here. I can do the conjugate root theorem, which tells me that -3i is also a solution, okay? And I can do synthetic division twice. Once with 3i and 1, 0, 8, 0. Okay. Now this is easier than the previous one because I've got these zeros in between. Which keeps the terms a little bit easier. Okay. And then I can reuse the coefficients, which are kind of yucky right now. Okay. Oh, all right. So I divided twice. So notice that these two things turn into factors. And you're like, oh, that's kind of weird. Yeah. Divided twice. So this is x squared minus 1. So I'm going to do this. Oh, sorry. Let me continue factoring. All right. In terms of vocab, this line is linear factors. Typically, I would stop here at this, which this one is a quadratic factor, and these other two pieces here are linear factors. But notice how I had to do synthetic division twice, okay? Your other option is to do long division. But in order to do long division, you have to take your two linear factors and you have to FOIL them. And then, instead of doing synthetic division twice, you do long division once. Okay, so it's going to be x squared subtract, bring down. Oh, look at that. Okay, look at that, guys. These are the factors right here. I know that you're thinking this is confusing because there's so many ways to do this, but these two things multiplied together, okay, are the factors of this question right here, which we happen to get another way. All of this work is connected. All right, but 1 and -1 are the real zeros. All right, so now it's a different question. It's asking me to write the equation. Notice that I'm going to build off of intercept form from quadratics. But because this is cubic, I'm just going to add another factor. So we have 0, 2, and 4. I'm going to change to capital A. 0, 2, and 4. Okay, I don't need to write this 0 here. And right here, it's giving me another point in order to find the A value. So I'm going to put a 45 in here, -1. Okay, right now I'm putting a -1 in for the x's. This is +3, so -15. Right, please be careful with your division. So -3 equals A. So what I'm going to type in, y equals, so we're going to say y equals -3 x, x minus 2, x minus 4. Next question. Oh, okay, similar idea here, but notice that we have radicals, and notice that I was actually given the conjugate zeros, and it told me that the leading coefficient is 1. All right. I'm going to take these two zeros and I'm going to turn them into my factors. Notice that I just subtracted both of these to the other side. And my preferred method of multiplying is the FOIL. Okay, feel free to set up the box if you'd like, but I'm going to FOIL like this first. Okay. Outer and inner cancel out. And last, it's -2. All right. Okay, let's put it together. X squared minus 10x plus 23. Okay, so look at how it's telling you to write your answer. X squared minus 10x plus 23 equals 0. If you were to solve this equation, you should get these two answers. You could even check it by doing opposite b over 2a plus or minus b squared minus 4ac all over 2. Okay, so here we get 5. Let's see, 100 minus 92, so that's 8. So that's 2 root 2 over 2. Wow, it works. Okay, next question. Okay, starting to put things together here. It wants me to write the equation in factored form. And here it says x equals -4, x equals -3. And I know from my studies that x-intercepts connect to factors. Okay, now it says A. So I'm going to put my A here and I'm looking at it. 1, 2, 3. Okay, so the point that I'm reading off the graph is 0, 3. So I'm going to go ahead and plug that in. So I'm putting a 0 in for each of my x's. 12 is 24, so 3 equals A times 24. Okay, please be careful. So that's 1 over 8. All right. So we're going to write Now notice it's saying y. So y, you don't want to use letters that are not introduced in the problem. And it says factored form. Whew. Okay, almost there. Next question. All right, linear factors. So this is kind of like what we started with. I have to know that this is the other factor. And I'm looking at this and I don't see any factors that are possible. So you have two choices. You can do the synthetic division with 3i and minus 3i, and you should get a remainder of 0. And then figure out what these numbers are and then try to factor from there. Okay, keep in mind that there are 4 zeros because the degree is 4, which means my answer is going to have 4 linear factors. One of them is going to be this. One of them is going to be this. I am trying to find the other 2. Now, I know that this piece here combines to the quadratic factor, x squared plus 9. So I could do long division with the x squared plus 9, which I actually think is easier than the synthetic division with the 3i and the minus 3i, just because there's so many coefficients and terms here. Okay, I'm going to put my x squared plus 9 out here. Okay, subtract. Bring down. So it's going to be, oh, that's an x, minus 3x. Oh, minus 27x. Put it in the wrong place. Don't want to do that. Subtract. Okay, so we get cross out. And we get minus 4. Okay, so minus 4. Minus, oh, okay, remainder 0. Awesome. All right, so we have this and this are the factors. Okay, so we have this. I see it, I see it, I see it. And this. We already know this piece breaks into these 2 linear factors because of the information that I started with. Okay, and I'm using all my other factoring techniques, x minus 4, x plus 1. All right, so my answer, this is what I would type for all of my linear factors. All right, let's do the last one, which is kind of similar, except we're still doing linear factors, but this time we have a kind of trickier. So I could do synthetic division, but yikes, I just don't think that I want to do synthetic division with this complicated of a 0. And so I am going to, 1, write in my conjugate 0, and I'm going to turn these into their factors because that's part of my answer. And because it's a degree 4, I have 2 more. And let's see what happens when I put this together. Now, I do like the FOIL method, but you may use the box. Okay, so first, outer, inner, last. All right. So plus 25. All right, so this comes together as x squared minus 4x plus 29. Now, I prefer to do long division with my quadratic factor. Okay, so x squared. Subtract. Oh, that was kind of cool. Positive 1. Oh, that was nice that it was really quick. Okay, remainder 0. And so right now, I know that these two quadratic factors result in this polynomial, but I don't want the quadratics. I want the linear. Well, I have two of the linears, okay? Because this one breaks into this because I was given this information, which are also zeros, okay? So I can take this part here and I can solve for the zeros. And I can take those and turn them into the linear factor.